Taylor's got a great presentation for us today. It's Payload Delivery Networks, abusing CDNs to bypass WAF and DDoS protectants. So a big round of applause for Taylor.
Thank you. First of all, thank you for coming to my talk, Payload Delivery Networks, abusing content delivery networks to bypass web application firewalls and DDoS protections. So in this talk, we're going to cover how to bypass WAF and DDoS protections from CDN providers, such as Cloudflare, AWS CloudFront, and Azure Front Door, by finding and attacking the Origin web server directly. We're going to look at the different ways Origin servers are configured to prevent this sort of direct access, and some of the surprising ways that they can be bypassed as well, including by using the CDN to bypass the CDN. We'll also discuss some more secure configurations and some various fixes that defenders can implement to prevent becoming victim to any of these attacks. The talk will mainly be from a red team perspective, as that is my day job, but we want to make sure defenders get something out of this too, so there'll be a lot of advice about how to fix these issues and why they occur. But before we do that, we might start off with a little bit of terminology, because there is a bit of domain-specific terminology and acronyms and things. So the Origin server is the first one. This is basically the target web server. So this is the web server that we're trying to attack, or that the attacker has interest for some reason, and that is protected by the CDN. The CDN, of course, is the content delivery network. So whether that's Cloudflare or Azure, you might have Akamai or Imperva or whichever one you use, which is basically a bunch of caching servers, or it typically was, that sit between the web application and the person, the website viewer, and caches content between them. The next one is the WAF, the web application firewall. So this is an application-aware firewall that inspects your HTTP requests and looks for potentially malicious traffic and blocks it at that application layer. And the last one is DDoS, so distributed denial of service, which many of you have probably heard before. It's about affecting the availability of an Origin server by just overloading it. So a little bit on the outline of what we're actually going to cover today and how it's going to be structured. We'll start off with the situation, how these CDNs are set up and kind of what it looks like to make requests between them, and be a refresher for most, but if you're completely new to this, hopefully it'll bring you up to speed so you get something out of the rest of the talk. Then we'll look at finding the Origin server IP, because if we're going to attack it directly, we need to know the IP. We'll then look at the Origin server protections you should put in place to prevent this direct access, and some of the bypasses for the different setups, depending on what you choose to go with. And then lastly, we'll do a bit of a summary and mitigations for more secure configurations and how you can avoid these attacks. Just as a note, we'll focus mainly on WAFs. Being from the red team background, that's more sort of my focus, but it does affect any of the security protections that the CDN provides, which is DDoS protection, it's bot management to stop scraping, and a whole bunch of other things that you can configure. Right? And as a second note, the concepts will apply to kind of all content delivery networks, not just Cloudflare, Azure and AWS, which will be the focus of this talk, but if you're running Akamai or Fastly or Imperva, the list goes on, the concepts will be largely the same, so you should still get a takeaway. Cool. So let's get started with the situation. So we have an attacker and we have an Origin server, and they sit on the internet, so they have kind of just their regular public IPs, right? And without CDN protection, this will be the first case. So we make a web request. Say in this case, we have a website called legittarget.com, and this resolves the DNS to the Origin server IP, and then we access it directly. Right? So the 192.0.2.1, that's just the public IP of the web application we're after. And we get a response. Right? There's nothing unusual here. It's pretty basic. In our case, we're going to use this a little bit, but the web application that we're testing against is just going to show back the IP that the Origin server observed requesting it. Right? And that's just going to be for debugging and working out what's actually happening. And we get the headers that go with it as well when you make the request. So if you have a malicious payload, so an example here, we just have a simple cross-site scripting, maybe a particularly trivial example, but it could be anything. It could be the latest CVE or some sort of template injection or whatever it is. But in this case, it's just some JavaScript that we have here. You can see the script tags and the alert function. and we send that to the origin server. It's a common vulnerability pattern, but the origin server doesn't know anything about it, so it'll just send back the request, and we can see the little pop-up that happens there, right? This is without the CDN protection, the WAF protection. The difference with the CDN protection is you put the CDN in the middle. So this is Cloudflare, it's Azure, AWS, whatever. And the origin is going to be protected by this. Right? The WAF and the DDoS protections are all going to live here. So we make the request to our website, and instead of the DNS resolving straight to the origin server, it's going to resolve to a bunch of shared IPs that are on the CDN provider. Right? So yeah, it's not going directly, it's going to the CDN. The CDN then has to work out how to route this to the origin server, so it looks at the host headers. So it sees that the host is a legit target, someone set that up on one of the providers, and it knows to proxy that to the origin server. So this particular part is not visible to the attacker. Right? It proxies the traffic. In this case, we get a response, and we can see that the web application shows us that in this case, Cloudflare IP reached out to it. We send that back to the attacker. Right. And if we put our vulnerability through here, the WAF should trigger and it will inspect the request. In this case, it says, oh, the request looks like cross-site scripting because maybe it has a JavaScript in the tags or something like that. And it can choose to block that request and give you this page instead of the actual one. So it doesn't reach out to the origin server, and you kind of prevent that. So that's basically how the WAF works in that case. But as an attacker, we still want to get our vulnerability across, right? So we have to think about how we can do that. Most research around it, and when you look this up and dig into it, will be about trying to trick the WAF somehow. You might be able to increase the payload size, and if it's sufficiently large, the WAF might not inspect it for performance reasons. That's a pretty common one. Or maybe you need to change your payload a little bit so it looks a little less like JavaScript and doesn't hit one of the rules, or anything like that. You can try and do, but that's not going to be the focus of our talk today. Instead, we're going to consider when we go completely around, bypass it by accessing the origin server directly. So before we do that, we need to work out what the origin server IP is, and there's luckily, for the attacker anyway, a large number of techniques to find this. So we'll look first at a bunch of passive recon and basically how much you can Google. The first technique is with passive DNS. So this is current and historical DNS records that help us find the origin server. There's many providers for this, like VirusTotal and Domain Tools. The list really goes on, but we'll work through an example with VirusTotal and see current and historical records that help us find the origin server. So an example here is a readout of VirusTotal, and it'll show all the DNS that is observed currently and in the past. So currently at the top, the most recent resolve will show the CDN IPs, because that's what the domain's going to resolve to. But you may also be able to find the origin server before you implemented the CDN. So it's the pre-CDN origin IP. And if you haven't rotated your IP since you've onboarded the CDN, which you definitely should, and in a lot of the documentation it does recommend you to do that, but surprisingly it's kind of common not to do that. But if we look at that IP, the 192.53.168.172 in this case, we see this is still a node server on the internet, and this is indeed our origin server. Second part of the passive records is the subdomains. So sometimes the CDNs won't proxy all the traffic that goes to an origin server. For example, if it's over a protocol that's not supported. We're mainly looking at HTTP and standard web applications. But if you're running something like SSH or FTP or have those other services, they may or may not be able to go through the CDN. And you may find that there's subdomains that go straight to the origin server to facilitate this access. And you may be able to work that out by taking a look. Next is the SBF records. So if you've got your email validation set up and it's coming from the web server, this is basically the IP that you're allowed to send emails from, and you can look at that and you may be able to find the origin server. Particularly useful if you're maybe looking at the Exchange server or something like that. Speaking of email, any emails originating from the application server or the origin server may contain the IP in the email headers. So it's worth taking a look if if you can. So this could be sign-up emails or password resets, or basically any time the application needs to send you a message as part of your application. You may find like receive from headers, and it may have the IP in there, or you may get an X originating IP header, which is commonly used for anti-spam and may be in there. It could be a different IP, but it may be the origin as well, so it's worth checking. The next is certificates. So we can search for certificates issued to the domain and look at historical records as well. Again, like the passive DNS, there's many providers for this. Census, Showdown, VirusTotal again, like so many. And we're just looking for certificates where the subject is the domain that we're interested in. So there's an example here. We can do it in Census. You just look for the certificate names in your query, and then we can see here that it shows us our Linode origin IP. Again, we can do the same thing in Showdown, SSL, legit target, and we can see that showing up as well, right? So it's the same for all of them. Just go through your favorite provider or whatever is available to you. The next one's similar lines, but a little bit different, is about favicons. So this is common for trying to find phishing domains that are emulating you, but in the same way you can find previous versions or the origin server as well. So we look up the favicon that you have that's hopefully unique, and we find any IPs that currently have or have had that favicon, and then try and work out the origin server from there. So for anyone who doesn't know, the favicon is the little icon that goes next to your browser window. And yeah, we'll need to search on a hash of that, and the hash is going to be a little bit different depending on which data source you have available to you. I also wanted to note on this one, when I tried it out in practice, you may have different versions of the favicon as well. So you need to look at the icon links in the page source to find the different versions of favicon. So in this example, we have favicon 32 by 32.png, because it's a slightly higher resolution, and we have this one, but you may have favicon.ico, or which is more common but kind of lower resolution. So just know that you may need to check a few of them if you're trying this technique. There's a few tools that help generate the hashes. As I said, they vary across providers. This is favicon-hash.kmsec.uk. Pretty handy. You just put the favicon link in there, and it generates different hashes and gives you links to Showdown, VirusTotal, and Census, and you can just click through. So in Showdown, we can see the search, and we get the same result as the certificate did. You can also see the hash there is a murmur hash 3. Without going into too much detail, it's an obscure hash that Showdown use for performance reasons, but it also varies across implementations a bit. So it's kind of weird if you're trying to generate this from scratch. You probably need to use the Python library, as some other languages produce different results, strangely enough. But in VirusTotal, it uses the MD5, although you'll need a higher tier subscription. So really, whatever's available to you, you should be using. And you can do the same techniques for any other unique identifiers, similar to how you find phishing sites, if you're familiar with that. So repeat with the process with anything that identifies a web page. So it might be a Google Analytics token, or a unique HTML title, or basically whatever you can think of. So that's the passive side, and now we'll talk a little bit about the active recon side. So if you're actually probing the web app, things that you may look for that may help you to determine the origin server. The first one is scanning the ASN or your IP block. So you just want to, if you have the IP block, so you're doing a pen test and you know your range, or you're a large enough organization that has their own ASN, you can just do a search and see if you can find the origin server, or do a scan. You may need to include the host header in case you get a load balancer or a virtual host or something like that. That's just a classic curl command to do it, but really depending on however you want to scan, it's up to you. This technique also assumes you won't run into any origin protections, which will be the focus of the next part of this talk. The next thing to look at might be headers and cookies. Surprisingly, inspecting the headers and cookies and other information in the web app can reveal IP leaks. So, for example, a load balancer may issue you a cookie directly to make sure that you go to the same server for your session, but sometimes the names may include kind of public IPs or more disclosure than you might expect. So example of this is F5 big IPs give you a server IP. Sometimes in the pool name, if the admin set it up that way, you may get a public IP, or maybe encoded values you may be able to take a look at and see if you can find something depending on the product. The next is server-side request forgery. For those who aren't familiar, this is where you try to get the web app to make a request on your behalf. And if you can do this and send it back to a domain that you control, you can see where that request is coming from and possibly ascertain the IP that way. An example of this might be if you have an upload feature and say you can give it an image URL and you want to upload it to that web application. The web application may take the image URL and then reach out to grab it so that it can upload it. Right. But you're kind of coercing it to make that request. So instead of doing a legitimate one or the image that you're after, you can just give it an attacker-controlled listener. So we'll use this out-of-band testing tool, out-of-band testing tool a couple times. Oh, it's not fun, but you give it that unique domain, and then you can just observe the requests that come back. So this is an example of it, and we can see the from IP address popping up in that, which might be our origin server. There may also be some more legitimate functionality that might call back. Possibly a callback for an API. So we have an example. Let's say you have an API that you need to submit a job. It might be training a large language model or submitting a scan or doing something that might take a couple hours or something that's past the timeout of a standard HTTP request. So you submit the job and then the API will call back to you later when it's done. So you get the notification and you can continue on doing what you need to do. But if you have control over that callback URL, then you can put it to something that you control and observe where that request comes from. Another example that's a little bit more specialized is the WordPress pingback. I include this in case anyone comes across a WordPress site because it is in by default and it's a little bit strange, but also an example of how common functionality that's included can let you direct requests. So a pingback is a special type of comment for WordPress that links back to any mentions of a blog. So the idea, if you make a blog and it gets popular and other people start mentioning you, you'll keep a record of that on your blog. The way it works is you have two blogs, blog A and blog B. Blog A makes a blog post, writes a blog. Blog B mentions blog A in a new post, and as part of that, it'll reach back out to blog A and say, hey, my post mentioned your post. Blog A says, okay, that's cool, and then it reaches back out to blog B to verify that it was mentioned. Right. So as part of that, blog B actually coerced blog A into reaching out to it. And if we observe that request, we may be able to get the IP out. So we have an example, just a out-of-the-box, straight default setting target WordPress site with surely interesting blog content. And we can craft a pingback message, which is basically just an XML message. We put my blog post in here, which is actually an attacker-controlled listener. And we can say that it mentioned your blog post, which is whatever the target is. We then send the XML pingback, so it's basically an XML RPC page that's included in WordPress by default. Ideally, you'd probably harden it so this isn't available, but in this case, it's available by default. And then we just observe the request that comes back and get the IP that way. So if you are running WordPress, it is on by default, and this is the setting here. Allow link notifications from blogs. And you probably want to turn that off and do some hardening, but if you're running WordPress, you probably want to do a fair bit of a hardening anyway, and this will probably be a part of it. Once you have the origin IP, just browse to it and see if it works, right? Just make the request, and maybe you'll get lucky and get back. However, if this is a residential IP or some sort of VPS, like attacker VPS, it's probably not expected to talk to the origin server. Right? If you've set up these CDNs, you're expecting that the CDN is the only thing that should be interacting with your origin server. Right? So most organizations will have some level of origin protection set up that prevent this direct access, and that's what we're going to cover now. And the first one we'll look at is possibly the most simple but prone to these attacks is allow listing IPs. So this is the layout of what it looks like. As we mentioned, the legitimate path is going through the CDN, and then only the expected IPs go to the origin server, and the illegitimate path is going straight to it, and we should be blocking that. So just using your normal firewall there. For Cloudflare specifically, they have documentation on this, as do the other providers. And they say that you should explicitly block all traffic that doesn't come from Cloudflare IPs. Makes sense, and they rate this as sort of moderately secure. If we look into what the IPs actually are, there's a list at cloudflare.com/IPs, and they give you an official list to work from. Right? But they also mention in this little blue note down there that Cloudflare also uses other IP ranges for various products, but they shouldn't be making connections to your origin server. So say that you really do need to use the IP address range that they have provided. And there's good reason for this. So this is the IP range here. It's just a bunch of IPs. They don't split it by services, so it is kind of all or nothing, plus the one they didn't mention. But they shouldn't be talking to your origin server anyway. So this is the official list. So as an attacker, the question becomes, how do we get a Cloudflare IP? Right. There are plenty of Cloudflare products out there, and which ones can we use to make requests on our behalf? There's Warp, there's Workers, there's a classic DNS, and interestingly enough, even iCloud Private Relay often uses Cloudflare IPs, so we have a bunch of products available to us. So we'll start off with perhaps the most simple, which is Warp. Right. It's effectively a free VPN client from Cloudflare. You don't need an account, you just download the client, and then you get Cloudflare IPs. Right. So you turn it on, and you get a Cloudflare IP. So in this case, 104.28 or 196, whatever. However, this would probably be a little bit too easy. Right? This doesn't work in every case. So because it's not in the official Cloudflare IP range. Right? So if we look for that IP in the official IP list, it's actually not there. Right? If you remember before, we had that little blue box saying that there are other various products that Cloudflare uses. This is included in that. Right? So that's not to say it doesn't work, though. It might work if you're allowing all traffic from the Cloudflare ASN, or you try to generate your own IP list or something like that. And I have seen cases where this does work, so it is definitely worth trying, and it is fairly simple to implement or test as a red teamer. Having said that, the documentation says to use the official IP list. So a question now becomes, what if we use that list? Are there other products that we can use that gives us a Cloudflare IP? So the next one, which was actually the first one that I looked at when I did this research, was the Cloudflare Workers. This is basically a way of running serverless code on the Cloudflare edge. Basically, you give it JavaScript and it'll run on a Cloudflare node. So you can make requests to your worker. It runs the Cloudflare Workers JavaScript code that you give it. And you can also make fetch requests using JavaScript. Right? So if I can fetch to websites from a Cloudflare node, I'm expecting Cloudflare IP here. So we can test that out. They have the Workers Playground that you can play around with. And apologies, it might be a little bit too small, but we just got the simplest thing where we're using a fetch to another attacker-controlled listener and just sending that off. You can see here, it reaches out and we can get our IP in the same way. If we look at that IP, it is actually in the official IP range, right? So we can cross-reference that list, and this is looking pretty promising, right? The next thing I was thinking about when I was doing this was, well, can we just proxy like all of our traffic through Workers, so some sort of like worker proxy? Which is indeed what I ended up developing. So this is the flow of how it worked. So an attacker makes a request like with a browser or with a HTTP proxy aware application. And use midden proxy sitting in the middle to redirect all the requests that are coming in to a Cloudflare worker. The Cloudflare worker then uses fetch to reach out to the origin server from its Cloudflare IP. Right. So if we look into the proxy here, we can see it takes all the traffic and redirects it to that Cloudflare worker. That's the workers.dev, and the subdomains like whatever worker you deploy. Redirects it to the worker, which has that official Cloudflare IP, and then does the fetch to the origin server. So the next thing to try is just to browse to the origin server IP directly. And unfortunately, it's not so successful the first time. So there's a restriction in Workers where you can't directly access IPs. So fetching 192.53. whatever doesn't actually work in this case. But we're not going to give up this easily. We've still got something we can work with. We can request domains, so the question becomes, how do we turn an IP back into a domain, right? Are there existing domains that resolve to our origin server IP? Or can we create a new domain record that points to it that we have? Right? These are our options. So if we look for existing domains that resolve to it, I came across a service called nip.io. You basically give the IP as subdomain and then go .nip.io, and the feature of it is it just resolves back to whatever you gave it. Right? So this seems kind of good for our use case. So we'll give that a go into that website, and it does work. The host header in this case is going to be the nip.io host header, so that is a consideration. But for all intents and purposes, we're getting the Cloudflare IP and making that connection. Also of note, if you're OPSEC savvy, the Cloudflare worker will get mentioned in here and included as headers, so just something to consider. But we can also make our own domains as well. So the next technique we'll look at is the imposter domain. So this is setting up your own domain in Cloudflare with the DNS pointing to the origin server. We're just going to let the CDN proxy the traffic in the same way that the legitimate flow works. Right? So instead of getting the legit target or whatever it is, we're going to get attacker controlled. That's going to go to the CDN, and that's going to route to the origin IP. Right? Because the CDN doesn't necessarily know who owns the IP, and you can have multiple domains pointing at that IP, so it'll let you set this up. And this is how we do it. We just go in the DNS records in our CDN provider of choice, in this case Cloudflare, and it will just proxy the traffic through. Then we just browse to our domain, and it goes through the legitimate Cloudflare IPs. We're in control of this zone, so we can control all the protections on it. While the legitimate zone is going to have the WAF turned on and everything else like that, our attacker-controlled zone, we can just turn the WAF off. We can turn off the caching if we wanted to do the denial of service attacks. We can do whatever we want with this and be as permissive as we want. Thing to note, as we sort of briefly mentioned before, the host header is going to be attacker-controlled .xyz here, right? Or the worker. In that example, it's the nip.io host header, so we do that. But is that really an issue? It is if the origin server validates the host. So if they've got a reverse proxy or something like this and it's actually looking at the host header, it might not work. So an example of this is in Caddy, like this is just setting up a Caddy file. If you set it up this way with legit target being the domain that you're trying to serve, and you have your reverse proxy in there, if you hit it with a different host header, it's actually not going to get proxied back to your target application. Right? So in some cases, the host header may actually matter, and you should be doing this host header validation as well if you want to save yourself from these attacks. As an attacker, though, we want to think, well, can we spoof these host headers? Is there a way to do that? In Cloudflare, you can do a transformation rule. So this applies to any incoming requests. It'll add a header on. So in this case, we try to add a header name host and make it legit target. But when we do that, we get this little red bar, which I've blown up here, and it says that set is not a valid value for the operation because it can't be used on the header host. Right, so we're actually being restricted on being able to change the host header. So if we look at other Cloudflare products, Cloudflare is restricting the host header modification pretty heavily, as I expect. For security reasons, so they basically require you to have a subdomain of a zone that's already associated with your account or something like this, which we don't because we don't have control of the legitimate domain. Right? So I can't see any way that we can actually spoof the host header in this case. So the summary for Cloudflare here is if you allow listing IPs, if it's restricted just to the Cloudflare ASN or that larger space outside of the official list, you may be able to use warp to do the workaround. And the mitigation for this is to restrict to the official IP list. Okay. If you're using the official IP list, though, creating an imposter domain with your own zone or using Cloudflare workers is a possibility to get a bypass. And you should be validating the host header to mitigate against this, against the legitimate domain, such as using the reverse proxy. Azure front door, the Azure CDN is somewhat similar. The documentation suggests IP filtering and header matching as an extra feature. But we'll look at IP filtering first, and a little bit differently to Cloudflare is that the Azure IPs are categorized by service tags. So there's a set of specific IPs that are only for front door, for the back end of it, that are talking to it, and won't be shared across other services in Azure. So a couple examples of some of the services we might want to have tried. So Azure Functions, kind of similar to Workers, or we have Azure VMs as well. But you can see they have different service tags compared to the front door backend. So you really should be restricting on the IP list that only is associated with front door and has that service tag. In addition, the documentation mentions to validate a header. This is the XTAC Azure TAC FDID or front door ID header, which is specific to your zone or your profile, I believe they call it here. And this is to avoid having imposter front door profiles. So in the same way we could set up an imposter domain, we could set up an imposter domain with front door, but you need to have this ID so that it ties back to your tenancy. And that's what they recommend. So the summary there is if you allow listing and it's not limited to that service tag for front door, you might be able to use the other services to get an Azure IP, but really you should be limiting to just that IP range. And if you do, an imposter front door profile may be an option unless you're validating that unique header, which you should be doing. Front door works basically the same way as Azure does. It says to use IP filtering and header matching. And the IPs are also tagged by service tags. So we have a CloudFront tag, we have an API gateway tag, we have EC2 tags. Lambda and EC2 share EC2 tags, probably because Lambda is kind of built on EC2. So yeah, a few products, but ideally you should be restricting just to the IPs that are CloudFront. So summary is, if you're not limited to CloudFront, you may be able to use the other services that we mentioned. Another note is that you can easily check the API gateway with Fireprox, which is a open source project that will just filter all your traffic through an API gateway. Fairly easy to set up. But if you are limiting to the CloudFront service tags, as the documentation recommends, you could do an imposter CloudFront distribution, but you should try and add the secret header to mitigate this. Similar to the front door option, although it's not included by default, but it is easy enough to set up anyway. Speaking of, that will be the next bit about secret headers. This is where you add the secret header in your incoming requests, and you drop any requests that don't have it on the header, right, on your reverse proxy. So when this CDN reaches out to your origin server, you're expecting that secret header to be added. You can do this in Cloudflare with the transform rules that we tried before with the host header, but in this case we just put like an XTAC secret header or whatever you want to call it, and give it a secret to put in. CloudFront gives you the option to do it as well. When you set up your distribution, it asks you if you want to add custom headers, so I'd recommend doing that in that case, but you can also do it after the fact as well. And as we mentioned before, Azure Front Door has the FDID header included by default, so you can just go ahead and use that. But in any case, whichever one you use, your request should be reaching the origin server with a secret header of some description, with some random unique key or secret that you can validate against. You then want to validate this header on your origin server, so probably using your reverse proxy to validate the host header, whether it's Apache, Nginx, or Caddy, or whatever it is. And you want something probably like this, where if that secret header is not equal to your secret, just return a forbidden or drop the traffic, or basically do anything that's not pass it on to the web server. Up to you. We should just be aware that it is potentially possible that static header might leak out. If you get something like a local file inclusion vulnerability and you can read the reverse proxy configuration, you may see the secret, and you can add it on yourself. Or maybe you have something like debug messages containing the request. So if you have some sort of API testing or like console logs or something, you may actually be able to see this, although it is perhaps a little bit less likely, but if you do find that value, you'd be able to add it to your request yourself. Right? So it's best to sort of like group these protections and implement a few of them. The next one is about certificates. This is particularly authentication between the CDN and the origin server. The first one we'll discuss is one that is known a little bit, and it's a Cloudflare specific feature called authenticated origin pools. This enables mutual TLS, or authenticated network connections, between Cloudflare and your origin server. This means that the origin server can reject any requests that don't present a certificate and that aren't signed by a specified certificate authority. So if you try to connect without a certificate, you'll get an error something like this. So you get an SSL client, auth cert's not valid, you don't have sufficient authentication to make that request. So the question becomes, as an attacker, which certificate do we actually need? Well, when you set up the certificate, by default, Cloudflare will offer to generate you a certificate from the Cloudflare certificate authority for your convenience. But that certificate authority is a public certificate authority that applies to the whole of Cloudflare. This means that you can use any Cloudflare certificate to make this authentication by default. So we can set up our imposter domain as before, using our attacker-controlled domain. And we can turn on authenticated origin pools. And then when Cloudflare reaches out on our behalf, it'll use a certificate that is signed by the Cloudflare CA, which means that we may be able to access the origin server and authenticate that origin pool. They do mention in the documentation that authenticated origin pools by default only confirms that the traffic came from Cloudflare, not that it came from your specific zone. So if we're creating our own imposter zone and using that, we can still say that it came from Cloudflare, but it didn't come from the Cloudflare zone that you expected, that has your WAF protections, that has your DDoS protections and everything else. If you want to tie it back to your specific zone, you can upload your own certificate instead. Right? And then on your origin server, you're just validating on the certificate authority that you own and that you're in control of, and that hopefully no one else can actually issue a certificate of. Right. Now for Azure and AWS, there's no native support or equivalent for authenticated origin pools, or the MTLS equivalent. The similar solution that's thrown around a little bit would likely require AWS Lambda or Azure Functions to do. So you would have to send it to the CDN, which would forward it on to basically the equivalent of a worker in Cloudflare terminology. You'd need to make that request and do the authentication there. You'd need to funnel all of your traffic through Lambda or Functions, which you may or may not want to do. And it's pretty custom and not a very common strategy for these providers. Instead, luckily we have other options that are good as well, and that will be sufficient. And this includes tunnels and VPNs, which we're getting to the parts where these are pretty good protections to have. So the first one is Cloudflare tunnels. So this connects the origin server to the Cloudflare network via a WireGuard-ish sort of tunnel, rather than communicating via public internet IPs. It basically means you can start dropping all inbound IP traffic, and the IP will effectively not be routable on the public internet. Right? So even if you know the origin IP, it's not usable, right? Because the legitimate flow is that we get our legit target, it goes to Cloudflare, and then it talks under that tunnel rather than by making a request to an IP. Then on the origin server side, there's an agent that sits there that just reaches out to the listening web server locally, and you don't have to use the public internet for that part, or IP. You can do this easy enough. You just set up the tunnels to talk directly to your web server locally in the Cloudflare dashboard, and it gives you instructions how to install the Cloudflare D agent, which is basically the WireGuard tunnel on your origin server. You give it the commands, it has an authentication token in there, and it just links back. And you'll see your tunnel activate in the Cloudflare dashboard. You'll also see that a CNAME record gets added, so that when you look up legit target, it's actually a CNAME record on the CDN side that goes to tunnelid.cfargotunnel.com. Argo tunnel is what they used to call Cloudflare tunnels before they rebranded it. So you see that this is the way that they link it back to your tunnel to know where to actually send the traffic, now that we're not using your public IP. Right. And that's a good thing to know, but yeah. On the origin server, just to make sure you're good to go, you should be dropping all the inbound traffic on your firewall. Just your standard firewall, just don't use that public IP now. But thinking about back to that CNAME and the way that we set that up, is it possible to do some sort of like imposter CNAME DNS record? So following in the same way that we did the imposter domains, can we do like an imposter tunnel and use a tunnel that's associated with someone else's zone in your attacker controlled zone? I'm not sure exactly how someone would get the tunnel ID, but if you somehow manage to do this, we can test it out and see whether it's equivalent to getting an origin IP. Can we just connect our target domain to the attacker controlled zone? So we can set up our attacker domain, and instead of putting the public IP in here, we're going to put the CNAME to that cfargotunnel.com address and see if we can resolve that. So if we browse to our attacker controlled domain, we see that Cloudflare does refuse to route this, and then we get an Argo tunnel error. So it appears that Cloudflare doesn't resolve the tunnels across zones. So if you set up a tunnel in your zone, it will be tied back to your zone. So feeling pretty good about this one. This is a good protection to have. Azure takes a little bit more of a traditional approach to this, rather than using the tunnels with the agent that Cloudflare does, and suggests you set up a VPN gateway. The VPN gateway then puts you onto a virtual net within Azure, and you can link that to your front door profile using those private links in the virtual public cloud, private cloud rather. You also don't need the IP because you're getting that VPN connection as well. So similar concept, slightly different implementation. AWS follows the same way that Azure does. They give you VPN, they give you a few different options. But you want to establish that VPN connection and drop all the other public IP traffic. The next one is dedicated IPs. This is if you go back to the idea of allow listing IPs, but you want to try and find an IP that's unique to your tenancy. Right? So this is a CDN IP, but not one that's used by workers or other shared services on the CDN, and one that's specific to your zone. That way you can safely firewall off all the IP traffic except for the one that comes from this very specific IP. This seems only to be available in Cloudflare. They have a product here that's available if you have an enterprise plan. But Azure and AWS don't typically support applying a static IP to profiles or distributions. And the last one here with the direct links applies to all three of them as another way to secure yourself. So here we have the attacker getting the domain for CDN. The CDN peers directly with a data center or some sort of connectivity provider. You can do it yourself if you have a networking team or you're large enough to do it. And then you can have a private network between the origin server and the data center. That way, you can get from the origin server to the CDN using those private links rather than using the public internet. So you don't have to have your public IP exposed again. So no need for the public IP, so the connection goes directly to the CDN provider rather than over the public internet. And therefore our bypass doesn't work. They call it a variety of names. Cloudflare call it the network interconnect. Azure call it express route, and AWS is direct connect. Usually enterprise only, or you have a data center that sort of works the connection out for you. So perhaps a bit more of a difficult setup for a lot of smaller places, but definitely an option if you have access to it. And now we'll talk a bit about the last part, which is the mitigations and the summary. So the first thing you should take note of as a takeaway is that you can assume that your origin server IP can be found. Passive recon makes it fairly easy. You should be rotating your IP after you onboard it because the historical records might give you away. Having said that, you can still do some informed guessing, particularly if you have a similar IP block or an ASN. We still may have some idea where the origin server is likely to be. Right. And you can't help it if you have some services like the SSH1 or FTP or whatever that point to your origin server. If you have any records that point to your origin server, they may be able to be found. But even if the passive recon doesn't find anything, active recon still may be possible. So it might be leaked out in headers and cookies, and maybe you can fix those. But there may be exploits such as the server-side request forgeries, where you can coerce the server into making a request and observe the IP. Or there could be legitimate functionality that's just inherent, such as callbacks and pingbacks and things that just exist and you can't really help it. Maybe some things you could try to proxy the traffic out of a different IP, but may or may not be possible depending on your setup. Second thing to keep in mind is that allow listing IPs restricts to the CDN IPs and not to your tenancy specifically. So allow listing the IPs only confirms your traffic comes from CDN, but you need to make it specific to your tenancy or your domain. Right? Follow the documentation, otherwise you'll potentially open yourself up to some risk. If it tells you to use an official IP list, you should use that list. Don't try to create your own or use the ASN or do anything too fancy. Just follow the official IP list. If you're using something like Azure AWS and they give you the service tags and say that IPs are only associated with CloudFront or FrontDoor or whatever it is, use that limited set of IPs so that you don't have the other services being able to talk to your origin server. In any case, you should validate your host headers on your origin side. The origin server ultimately is the thing that you control as a defender. So if you validate those host headers, you can make sure if you're using those other imposter domain techniques that give you the weird host headers of the attacker control domain, if you're validating with the legitimate one, that technique will no longer work. And you may want to complement this with other protections as well, such as the secret headers that can be used as another option to tie it back to your tenancy. Which was included in FrontDoor and recommended and fairly easy to set up for CloudFront and Cloudflare, where you validate on the origin server, such as through your reverse proxy, that header has gone through your zone or your profile distribution, whatever you want to call it, and is unique to you. It can possibly be leaked, so it's something to keep in mind as well. If you're using authenticated origin pools, just note that they're not tenancy specific by default. It only confirms that traffic comes from Cloudflare by default, and not that it came from your specific zone. If you want to do that, you need to use a custom certificate and tie it to your certificate authority that way. It's not easily available on other providers, although you may find outside of the three that we've looked at, maybe it is provided as well. But ideally, what you want to do is ditch your public IP altogether if you can. So tunnels and VPNs can be used to make the private network links, and then you can just stop using your public IP altogether. Direct links are also an option if you have the infrastructure, such as the data center link, and you can onboard your origin server effectively to your private clouds. And you just block all the inbound traffic coming to your public IP, or just take that interface off if you can. And the last one was about the dedicated IPs is also an option if you're a Cloudflare enterprise customer using a Cloudflare product to get a tenancy-specific IP. So it may be useful if you have some legacy products or you're limited in the protections that you can implement for whatever reason, and that will give you a tenancy-specific IP. However, it doesn't appear to be available on other providers, and just keep that in mind that it might not always be available to you. And that leads us to the end of the presentation. So if we have time, I guess I'll pass over and maybe answer a question or two. Thanks.
Great talk. Do we have any questions from the audience? Just raise your hands if our runners can see you.
is over here, sorry. Did I hear correctly that you mentioned it was non-routable to the sort of private internal DNS from a different service?
Sorry, what was the question?
You mentioned it is a very minor point, but I think the details matter, having worked on the space bit. It sounded like when you tested in Cloudflare, if I set up another Cloudflare service that's not on the same account, but I know the Cloudflare seemed to have a ability to set up a tunnel which had its own DNS for how that was resolved.
Yep.
You're saying you couldn't resolve that from a different service?
So I believe this is to do with the tunnels.
Yes.
When the tunnels, the question is about tunnels and whether you can resolve that in a different zone. So you set up your tunnel going for your zone and you get given a tunnel ID. And that's basically a CNAME record on the CDNs part. If you would grab that CNAME record and try and make the same DNS configuration on a different zone, like your attacker-controlled zone, it doesn't allow you to do that. Cloudflare will just give you back an error and it won't route it. I'll see if I can find the slide.
Thanks. That's super interesting because there's technical reasons that surprises me behind the scenes. Second question, if I may, I don't see too many other hands, but did you see mutual TLS for the back end come up? Because I didn't see that as one of the options.
So the mutual TLS we saw in the form of authenticated origin pools on Cloudflare. That had a way of putting it in. For the other providers, there wasn't any native way to implement it that I could find. You could implement it by using like Azure Functions or AWS Lambda, using the custom solution to do it, but I couldn't see anything sort of built in. So it depends on your provider, but the Cloudflare mutual TLS is the authenticated
that
origin.
fits. Other providers provide it too, that's fine. I think I don't want to detract too much. Really great talk as someone that knows the space really well. I would recommend, if anyone here in the room at least hears this, verify your accounts have MFA, because take-up was incredibly low amongst the customer base, and it really shouldn't be. And make sure everyone logs what they should from their CDN, because it's incredibly powerful. But thanks, great talk. I don't see the runners to give the mic back.
Cool, thank you.